The hardware required for tapping into an existing bus for a 1200 amp 480/277 volts distribution includes several key components. Firstly, you'll need a disconnect switch rated for 1200 amps and equipped with mechanically interlocked doors. Secondly, a bus transition fitting is necessary. This allows for connection to the existing bus while providing electrical isolation. Thirdly, you will require secondary switchgear. This electrical switchgear should be rated for 1200 amps and designed for the desired voltage, which is 480/277 volts. Fourthly, conductors are needed. These should be high-voltage copper conductors rated for 1200 amps and with 480/277 volts insulation. Fifthly, bus splice plates and bolts are essential for connecting conductors to the bus transition fitting. Sixthly, terminal lugs are needed for connecting conductors to the disconnect switch and secondary switchgear. Seventhly, a grounding system is crucial. This includes a grounding conductor, lugs, and a grounding connection to the disconnect switch and secondary switchgear. In terms of drawing details, there are several essential components that the city will likely require. 1. A single-line diagram, which shows the existing bus configuration and the proposed tapping point. This should include the disconnect switch, transition fitting, secondary switchgear, and grounding system. 2. An isometric drawing, which provides a three-dimensional view of the physical connection between the existing bus and the new circuit. This should show the location and orientation of the bus transition fitting, splice plates, conductors, and terminal lugs. 3. A schedule of materials, which lists the quantities and specifications of all hardware required for the project. This should include the disconnect switch, transition fitting, secondary switchgear, conductors, and other components. 4. Installation instructions, which provide detailed steps on how to safely install the hardware and make the electrical connections. This should include safety precautions, torque specifications, and grounding procedures. Additional important notes to consider include that the details and drawings should be prepared by a licensed electrical engineer. The installation should be performed by qualified electricians in accordance with applicable electrical codes. The city may have specific requirements or specifications that need to be met. It is essential to consult with the city's electrical inspector before proceeding with the project. When dealing with high current and high voltage systems, safety should be the top priority. Therefore, each piece of equipment plays a specific role in ensuring a reliable and safe electrical connection. Starting with the disconnect switch, this component provides a means to isolate the new circuit from the existing bus. Its rating of 1200 amps ensures it can handle the full load current without overheating or failing. The mechanically interlocked doors are a safety feature, preventing access to lift parts when the switch is in the on position and preventing the switch from being turned on when the doors are open. Next, the bus transition fitting serves as the physical interface between the existing bus and the new circuit. It must be designed to maintain electrical isolation, preventing short circuits or ground faults. This fitting typically includes insulated barriers and robust connection points to ensure a secure and reliable connection. The secondary switchgear is a comprehensive assembly that includes circuit breakers, fuses, and other protective devices. It is essential for distributing power to the new circuit and protecting against overloads, short circuits, and other electrical faults. The switchgear's 1200 amp rating and 480/277 volts design must match the requirements of the connected loads. The conductors, typically made of high voltage copper, carry the electrical current from the existing bus to the secondary switchgear. The conductors must be sized appropriately to handle the 1200 amp current without excessive voltage drop or overheating. The insulation must be rated for 480/277 volts to prevent electrical breakdown and ensure safety. Bus splice plates and bolts are used to securely connect the conductors to the bus transition fitting. These plates must be made of a conductive material, such as copper or aluminum, and designed to provide a low-resistance connection. The bolts must be properly torqued to ensure a reliable electrical connection and prevent loosening over time. Terminal lugs are used to connect the conductors to the disconnect switch and secondary switchgear. Like the splice plates, These lugs must be made of a conductive material and designed for the specific conductor size. Proper crimping or bolting techniques are essential to ensure a secure and reliable connection. The grounding system is a critical safety component that provides a path for fault current to flow back to the source, allowing protective devices to trip and de-energize the circuit. The grounding conductor must be sized according to applicable electrical codes and connected to a suitable ground electrode system. The single-line diagram is a simplified representation of the electrical system, showing the major components and their interconnections. It is essential for understanding the overall system configuration and troubleshooting problems. The diagram should include the existing bus, the proposed tapping point, the disconnect switch, the transition fitting, the secondary switchgear, and the grounding system. The isometric drawing provides a three-dimensional view of the physical connection between the existing bus and the new circuit. This drawing is helpful for visualizing the spatial relationships between the components and ensuring that there is adequate clearance for installation and maintenance. The drawing should show the location and orientation of the bus transition fitting, splice plates, conductors, and terminal lugs. The schedule of materials is a comprehensive list of all the hardware required for the project. It should include the quantities, specifications, and part numbers of each component. This list is essential for ordering materials and ensuring that all the necessary parts are available for installation. The installation instructions provide detailed steps on how to safely install the hardware and make the electrical connections. These instructions should include safety precautions such as de-energizing the existing bus before starting work, wearing appropriate personal protective equipment, and following lockout/tagout procedures. The instructions should also include torque specifications for all bolted connections and specific procedures for grounding the system. It is crucial to emphasize that these drawings and details should be prepared by a licensed electrical engineer. Electrical engineers have the knowledge and experience to design safe and reliable electrical systems. They can perform calculations to ensure that the components are properly sized, and they can create detailed drawings that meet all applicable codes and standards. Furthermore, the installation should be performed by qualified electricians. Qualified electricians have the training and experience to safely install electrical equipment and make electrical connections. They are familiar with applicable electrical codes and standards, and they know how to use the proper tools and techniques. When tapping into an existing bus, it is essential to coordinate with the local utility company and the city's electrical inspector. The utility company may have specific requirements for connecting to their system, and the city's electrical inspector will ensure that the installation meets all applicable codes and standards. In addition to the hardware and drawings, there are several other factors to consider when tapping into an existing bus. These factors include the available space, the load requirements of the new circuit, and the potential impact on the existing electrical system. Before starting the project, it is essential to perform a thorough site assessment to determine the available space for the new equipment. The disconnect switch, transition fitting, and secondary switchgear can be quite large, so it is essential to ensure that there is enough room to install them safely and efficiently. The load requirements of the new circuit will determine the size of the conductors, circuit breakers, and other components. It is essential to perform load calculations to ensure that the new circuit will not overload the existing electrical system. Tapping into an existing bus can have a significant impact on the existing electrical system. It is essential to consider the potential for voltage drop, increased fault current, and other adverse effects. A power assistance study may be required to assess the impact of the new circuit on the existing system. The grounding system is of paramount importance in electrical installations, especially when dealing with high current systems. A properly designed and installed grounding system protects personnel and equipment from electrical shock and damage in the event of a fault. The grounding conductor, typically made of copper, provides a low impedance path for fault current to flow back to the source. The size of the grounding conductor must be determined according to applicable electrical codes based on the size of the service conductors. The grounding electrode system, which is the connection to the earth, can consist of ground rods, ground plates, or a combination of both. The grounding electrode system must have a sufficiently low resistance to ground to ensure that fault current can flow quickly and safely. In addition to the main grounding system equipment, grounding conductors are required to connect the non-current carrying metal parts of electrical equipment to the grounding system. This provides a path for fault current to flow back to the source, allowing protective devices to trip and to energize the circuit. The equipment grounding conductors must be sized according to applicable electrical codes based on the size of the circuit conductors. Bonding is the process of connecting together all non-current carrying metal parts of electrical equipment to create a continuous electrical path. This ensures that all metal parts are at the same potential, reducing the risk of electrical shock. Bonding is typically accomplished using bonding jumpers, which are short lengths of wire or metal straps that connect the metal parts together. Surge protection is another important aspect of electrical system design, especially in areas that are prone to lightning strikes or power surges. Surge protective devices, or SPDs, are designed to protect electrical equipment from damage caused by voltage spikes. SPD are typically installed at the service entrance and at downstream panels to provide comprehensive surge protection. Arc flash is a dangerous electrical hazard that can occur when there is a fault in an electrical system. An arc flash can produce intense heat, pressure waves, and toxic gases, which can cause serious injury or death. Arc flash studies are conducted to determine the potential arc flash hazard at various points in the electrical system. The results of the arc flash study are used to determine the appropriate personal protective equipment, or PPE, that is required for working on or near energized electrical equipment. Lockout/tagout procedures are essential for ensuring the safety of workers who are performing maintenance or repairs on electrical equipment. Lockout/tagout procedures involve energizing the equipment, disconnecting it from its power source, and applying locks and tags to prevent the equipment from being accidentally re-energized. These procedures help to prevent electrical shock, arc flash, and other electrical hazards. Electrical codes and standards, such as the National Electrical Code, or NEC, provide comprehensive guidelines for the safe installation and maintenance of electrical systems. The NEC is updated every 3 years to reflect the latest advancements in electrical technology and safety practices. It is essential for electrical engineers, electricians, and other electrical professionals to stay up to date on the latest requirements of the NEC. Continuous training and education are essential for electrical professionals to maintain their skills and knowledge. There are numerous training programs and educational resources available to help electrical professionals stay up to date on the latest technologies, codes, and standards. These programs cover a wide range of topics, including electrical safety, power system design, and motor control. In addition to the technical aspects of tapping into an existing bus, there are also important project management considerations. Effective communication and coordination are essential for ensuring that the project is completed safely, on time, and within budget. It is important to establish clear lines of communication between the electrical engineer, the electricians, the utility company, and the city's electrical inspector. Regular meetings should be held to discuss the project's progress, address any issues, and coordinate the work of the various stakeholders. Risk management is another important aspect of project management. A risk assessment should be conducted to identify potential hazards and develop mitigation strategies. The risk assessment should consider factors such as electrical shock, arc flash, equipment damage, and schedule delays. Contingency plans should be developed to address potential problems such as equipment failures or unexpected site conditions. Quality control is essential for ensuring that the installation meets all applicable codes and standards. Regular inspections should be conducted to verify that the work is being performed correctly and that all materials are of acceptable quality. Any deficiencies should be corrected promptly to prevent problems later on. Documentation is an important part of any electrical project. Detailed records should be kept of all design calculations, drawings, materials, and installation procedures. These records can be useful for troubleshooting problems, performing future maintenance, and demonstrating compliance with codes and standards. In summary, tapping into an existing 1200 amp 480/277 volts bus requires careful planning, design, and execution. It is essential to use the proper hardware, follow applicable codes and standards, and employ qualified personnel. By paying attention to all these factors, it is possible to tap into an existing bus safely and reliably.